Hey everyone, welcome to Sequence of Instructions. I'm here on Leetcode about to do a medium difficulty algorithm problems called add two numbers. Alright, so let me read through the description really quick. You're given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order and each of their nodes contain a single digit. Add the two numbers and return it as a linked list. You may assume the two numbers not contain any leading zeros except for the number 0 itself. Alright. So this is the number 342 because it said they're stored in reverse order. This is number 465 and they sum to 807. Now I have a confession. I started this exercise or this problem a few days ago. I was going to do a video on it, and the solution I was going to use was going to be iterating through these, basically converting them into a string representation. So using string concatenation to build this number in a string, parse it to an integer, add it, and then basically reverse that process, convert it back to a string, iterate through it, and build a linked list that way. And what I built worked, but when I went to submit it, I had forgotten the cases or hadn't considered the cases where the number was huge. So one of the tests that they had in there was like 20 digits long or something, and there's really no way, you can't convert that into a number, it'll overflow, and so my solution didn't work. And so I had to abandon the video because I like to keep the videos pretty short, and so I was like, alright, well, I'll have to think of a way to do it. And in the meantime, I thought of a way that might work that I'm now going to attempt in this video, and if it doesn't work, none of you will ever know that I had this embarrassing second attempt that failed because I just won't post this video. It's that simple. But alright, so the way I think I'm going to do it is because each of these is a single digit, and because they're in this reverse order, we can sort of do the addition as we go, carrying any like 1 remainders. So we can do 2 plus 5 is 7, write it out. 4 plus 6 is 10, so we would write a 0 and carry a 1, and 1 plus 3 plus 4 is 8. So that's the way that I think is probably the best way to solve this. It hadn't occurred to me in the first case because it's a little more complicated than my first approach, but it will handle the cases where the numbers are gigantic. So I'm going to attempt to implement that one, and hopefully this time around it does work. So let's get at it. All right, so I have my two lists, L1 and L2. I'm going to have a ret val. This is going to be the head of my new list. I guess it equals null. And I'm going to have this do something while L1.next, or while L1 or L2. I guess or will have a remainder value. So the remainder value is going to be if the two numbers add up to greater than 9, so 10 or up. We're going to have the remainder value just be, it'll never be larger than 1, but I'm still going to store it as an integer. All right, so do basically want to say if L1 so if L1 I'm going to build a new node equals list node. Maybe I'll do it at the end. Okay, I need to pass a value to this list node function. They have the function definition up here, so you can build new nodes using this function. So they have list node, you pass it a value, it's going to store its value, and then you can later set its next value. Alright, so if there's an L1, because it's possible that we extend beyond the bounds of the L1, like L2 might be a much larger number than L1, in which case L2 will have more digits, but L1 will have run out. So we want to make sure that we're still pointing at an L1, and we're going to say, let's do this, and L2. So if there's both, we're going to do what? We're going to do this val equals L1.val plus L2.val. Alright. We'll have to handle some case where they're not both there, but let me do this part to get the remainder. if it's greater than 9, it's 10 or up, then this val minus equals 10. And, sorry if you hear that motorcycle. And our remainder value equals 1. Alright, so plus remainder value equals 0. So we're going to add it. If there was a remainder, we add it to L1 and L2. Actually, we should do this in a separate step, because we're going to have to do it more than once. So now we're going to go if remainder value. We don't even need to check it, actually. This val plus equals remainder value. God, why do I keep pasting that? And then we reset remainder value. Alright, so this is going to work in the case where there's both an L1 and an L2. We're going to get their sum. We're going to add the remainder to it. We're then going to check if we're over 9, if we're 10 and up. If we are, we drop 10 points. We add the remainder value back in. Make a new list node of this val. Go on to the next one. Oh, wait. And we need to do L1 equals L1.next. L2 equals L2.next. So we move them both up 1. But don't save that. So I have a habit where I always Control S when I'm coding because I save stuff, and on Leetcode that's not necessary. Anyway, okay. So, but what if this is not the case? All right. Well, now let's check. Well, is there an L1, which means there wasn't an L2? We're going to do just the first part. This val equals L1.val. L1 equals L1.next. I'm trying to think if I can combine these somehow intelligently. And if I can, I'll refactor it, but nothing's coming to me at the moment. L2 equals L2.next. And then this last case is they're both empty. So what do we do when L2.nexts? What do we do when we've passed both of them? Then I guess we're done, right? We just want to break. I'm going to put break here, but I'm not exactly positive that's what we need to do. Okay, so I have this new node. I need to do... so ret val is going to be the head one. And I need one that's going to follow through. So I need to always record... Where's my thing here? I need to, once I create this 7, I need to always remember that's my head of my linked list, so I can return this. But I need something that, once I add the next to 0, I need something that tracks the current place we're on so that I can set its next to the new node. So I'm not sure what the convention is for the name of this thing, but I'm going to call it a walker. It walks the list. And here what we're going to do is we're going to say if ret val equals, I guess if not ret val, so if it's null or undefined, or in this case it would be null, I'm going to do ret val equals new node, and my walker is new node too. And I'm going to put walker, sorry, otherwise ret val walker.next equals new node, walker equals new node. So I save the next. So if we're on the first one, we come through here. New node is going to be 7. Ret val doesn't exist. We're going to store ret val to 7. Walker is also going to be stored to 7. The 7 node, not just 7, the 7 node to be specific. We go on to the next one. We make a new one. It's going to be a 0. Our new node is now a 0. Ret val does exist, so we're never going to do this again. Instead, we're going to say walker, which is 7.next equals new node. So 7's next to 0. Walker now points to the 0 node, and we repeat until both L1 no longer has a value, like is null, or L2 is, and L2 is null. Then we break out of this loop. Wait, now hold on now. What if there's a remainder value? Else, if remainder value. Yeah, if the last 2 digits were both 9s, or greater than 5, or they sum to greater than 10, we need to account for that, don't we? So if there's not a remainder value, we can break. If there is a remainder value, we need to add it to this val. And this val's got to start as 0. Otherwise, you can't add nulls to things. Right, so I can't add null plus remainder value. So this val's got to start at 0. Yeah, so if there's no remainder value, then we're out. So basically, if there's no value on this digit for either list, either number, both numbers are exhaustive numbers, and we didn't have remainder value from the last iteration, then we can break. Otherwise, the value is the remainder value, which is going to be 1. This is not going to be true, and make a new list of 1. Okay, I think this might work. Should we test it? Oh, wait. And I'm missing the important part. Returning ref val. Duh. So let's just run through this one more time. So we have our 2 lists. We're going to do this no matter what. This val is going to start at 0. This val being the value of the digit we're currently adding. So 4 and 6, this val is going to store the sum of that. It's going to come through. Say if there's both of them, this val is going to be the sum of them. Otherwise, if there's only 1, this val is going to be just that 1. This val could be 0. We're going to add the remainder value. It could also be greater than 10. We're going to add whatever the remainder value was, reset the remainder value. If the remainder value was already 0, this is going to do nothing. But so it's okay to have it, not in a condition. Now we're going to check. If this val is larger than 9, we drop 10 points. We put the remainder value to 1 for the next iteration to be added on here. We create a new node from this value, and this is where we string them together. All right, I think this might work. And we're gonna keep doing it as long as there's an L1 or an L2 or a remainder, which should match these. L1 or an L2 or a remainder. All right, let's do it. Man, I hope this works. All right, that one worked. Okay, let's try. Submit it. I did it. I feel so vindicated. Let's see how we did. I don't even know if I want to know. This one was harder than I thought it was going to be anyway. Not good. Man, and I thought about that for a few days, in fact. Okay, well, let's see how can we have improved this. I learned recently, that's why I wasn't doing this in the previous videos, but you can actually click on these and see how, like, the fastest person did it. So, what is going on? Oh, interesting. Oh, so here's how they broke up my if-else-ifs. Ah, nice, nice, nice. Temp equals sum. Sum, I guess, is there a remainder? Oh no, add num j is the remainder. Sum is the sum. Modulo's it. Cool. But it already moduloed it. What? So basically, well, this person's basically, I'm a little hung up here though. If they modulo, if some, oh, temp modulo. Sorry, I thought they were overwriting temp. Never mind. Okay, so basically what this person's doing is they're building an array. They're building an array of all the digits, and then what do they make the list node? Oh, these cheaters, dude. These guys are cheaters. It's only scoring it if it's two-stringing the list node into array notation. And so he's just returning an array. He's cheating. All right, well, I don't feel so bad anymore. Is that what this person did too? They didn't even return a linked list. They didn't follow the protocol. I'm so upset. No, this person looks like they returned. Whoa, this is hefty. All right, I'm not going to go through this. This video is already getting a little bit long. But yeah, so my solution wasn't great. There are some people who did better. Apparently, if you do really good, you're a cheater in this case. But I encourage you all to check these out, see how these other developers approached it. I'll be examining these for the next few minutes, maybe longer, in fact. I find this pretty interesting. It's a good way to improve your coding ability. You can see how other people approach these problems, and maybe you can pattern recognize for the future, get better at it. Let me know how you all approached it, if you beat me, and different ways that maybe you thought of solving it. Leave comments. Thanks for watching. Till next time.